The job of a router is to deliver packets across the network and over the internet. The router uses a routing table to determine the best path. When a host sends a packet to a device on a different network, it is sent to the default gateway. If you want to see your routing table, you can use the command do show IP route. There are 3 packet forwarding mechanisms that a router uses. Process switching is an older mechanism. When the packet arrives, it is forwarded to the control plane where the CPU works. The CPU will match it where it needs to go, and then it is sent out. This is slow, steady, and inefficient. Fast switching is a more common method. The packet arrives, is forwarded to the control plane. The CPU will attempt to match the destination with a cache. If it's unable to match, it will handle the packet just like process switching. Otherwise, it'll send it using the fast switching cache. If another similar packet arrives, it'll send it immediately without going to the control plane. And then we have Cisco Express Forwarding, or CEF. CEF has a fast switching cache, just like fast switching, called the Forwarding Information Table, or FIB. There's also a table called the Adjacency Table. Changes to this table are made when the network topology changes. So, if a route goes down, the tables will change. When it comes to creating your network, there are many pieces. Let's talk about the bare bones part of a network. A network will have an edge router. This is a router that is the separator between a LAN and a WAN or service provider. For a host to access the network, they will need an IP address and the subnet mask. If they want to communicate with the internet, they will need the default gateway. If you attempt to communicate in the local network, this is called local communication. Any attempts to connect outside of the network is called remote communication. Let's talk about some steps for configuring your router. You can configure a hostname with the hostname command, followed by the hostname of your choice. Within tech, most things you remotely connect to will have a message of the day, or MOTD. Most of the time, this is used for the usual blah 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 blah, only log in if you're allowed message. You can set a banner by typing banner MOTD with a symbol, your text, and then the symbol again. There's a password you need to configure called secret. Secret is a layer of security over your privileged exec mode. To enable secret, type enable secret followed by the password you want. Now, you'll want to configure your console. We've already covered securing virtual terminal lines, but to configure the console with at least a password is an important task. Do line console 0, then password with a password. After that, type login and then type exit. Be sure you encrypt all of your passwords with the service password encryption command. Let's talk about configuring an IP address to an interface. Remember how I talked about links between routers or their own networks? This is where that comes in. Let's say this interface is one end of the link. If we do int followed by interface, we can configure it. We can add a description here if we want to. If we wanted to call this the WAN link, all we would have to do is type description and then add our description here. After this, you can configure an IP with the IP add command, followed by the IP and the subnet mask. These links are not on by default, so you'll want to type no shut to turn them back on. Here's some commands you can do to view your interface and routing configurations. Let's talk about the whole routing process. The process of sending a packet to a different network has a bunch of steps to it. The first thing that needs to be done is the PC checking its own subnet and the network address with ANDing. If the ANDing concludes that it's within the same network, the router isn't needed. If it is a part of a different network, the PC will need to send the packet to the default gateway. Now, Router 1 will check the routing table for a network address that would match the destination address. If the router has an entry match, it will prepare the packet for the next hop. This is done by re-encapsulating the packet with the MAC address of the next interface the packet will go to, which is the interface of the next router. Once the packet arrives on the second router, the router will check the destination to see if it can send the data. From here, it will check the destination IP with its ARP cache. ARP stands for Address Resolution Protocol, which is a way for a device to find the MAC address based off an IP address. The cache itself will have IP addresses MAC to MAC addresses. If the router doesn't have it, it will request the MAC address with the IP address. Eventually, the packet will arrive at its destination. Now ultimately, the router will select 3 routing decisions. Directly connected network, which means it will be sent to the host. Remote network, which means the packet will be forwarded to the most appropriate interface. And then, no route determined, which is where the packet will be sent to the gateway of last resort, which is the route that is used if the router cannot determine the right route. If there is no gateway of last resort, the packet is dropped. Otherwise, hopefully it finds its way. To determine the fastest route, routers will check the hop count versus bandwidth as a unit of measurement, or metric. There are some dynamic routing protocols that can be used to automate this process of connecting your networks. These include Routing Information Protocol, Open Shortest Path First, and Enhanced Interior Gateway Routing Protocol. When a router picks from the routing table, it will use administrative distance to pick. As shown in the chart here, you can see the different routing protocols. The lower the administrative distance, the better for a route. Routing tables store 2 different types of routes, directly connected routes and remote routes. Directly connected routes are connected to an interface, while remote routes are either statically configured or dynamically configured. If you type do show IP route, you can review the routing table yourself. Here are some common codes in the routing table. This is a routing table entry. The router source identifies how a destination was learned by the router. The destination network is the address of the remote network. The administrative distance is the trustworthiness of a route. The metric is a value assigned to a remote network, where lower values are better. The next hop is the IPv4 address of the next router to forward the packet to. The router timestamp is how long the router has known that route, and the outgoing interface is the physical interface the packet will go out from. At Layer 4, it is decided that TCP ports 20 and 21 will be used because my client is pre-configured to use them for their reliability and because ports 20 and 21 are widely accepted for file transfers. That's it for this episode. In the next episode, we're going to be taking a look at inter-VLAN routing.